Hi, everybody. Welcome back to CSE 1322. Today, we are going to cover module number 4, which is the beginning of graphics and GUI programming, which is at least very different than what we've been doing in module 3, which, if I had to guess, you're all sick of module 3 by now. Number 4. So the first question that you might have is, what is a GUI and why are we talking about it? So GUI stands for Graphical User Interface, which is probably something you've heard of before. And it is a replacement or a different way of doing interaction with users. So way up until the 70s, basically, every time that you had a computer and somebody was running any kind of interaction with it, they were looking at something very like this output window, which is what we've been looking at this entire time. You might remember the silly little guessing game that we wrote in the first week. So I'm going to enter in my guess, and my guess is going to be the number 6, and it says, you guessed correctly. Okay, well, that was very exciting. But this style of interaction where it is just plain text and the user types in their answer and then it either says yes or no or asks them for more information, I mean, there's still a place for that in the world, but there's a limited place for that in the world, if we're being honest. Most everybody nowadays expects a graphical user interface. And interestingly enough, if we actually look at this window, I'm really looking at a graphical user interface. It's just that this text area that I've been dealing with is only over in one corner. So of course, what you're looking at here is Chrome. And Chrome is a graphical user interface. It allows you to type in a URL up here, and then it shows you the web page, as you are well aware. And then inside of that, we have elements of a graphical user interface, like we have menus that I can expand and I can retract over here. They're only visible when I want them to be visible. We can move around the different windows and make them bigger or smaller depending on what my needs might be. And I can go to completely different screens by, clicking around in a menu. I can go back to my home screen or I can go back somewhere else. So the idea of a GUI is effectively to take what people are expecting nowadays and making it so that everything is in a pleasing way so that it's easy for the user to interact with the program. So you're going to be writing some graphical code this week where you're going to do a little bit of drawing some stuff on the screen. You're also going to do a little bit of laying out a UI for somebody to interact with. You will notice that the programming style ends up being a little bit different when you're dealing with a UI where you're asking the user to interact. So up until now, we have printed out, hey, give me a number, and then we expect the user to give us a number, and there's really nothing else the user can do except to give us a number, and we are going to wait there forever. But if you think about it in a GUI, that's really not how it works at all. I can come up here and I can open a new tab, and then I can start loading a page in here. So there's the CCSE Kennesaw, but while that's loading, I can go back over here and I can find one of my replets and I can run that little guessing game again. And I can have multiple different things going on in different places, and I can be interacting with them in a different way. It's all based on what I'm doing as a user. The user is deciding which part of my code is running next. When I click here, I asked for it to do one thing. When I click here, I'm asking for it to do another thing. When I click here, and your entire computer is like that, right? You can pull up the volume button down here, or you can change, anything. Everything reacts to the user's clicks. So that's a very different way of coding because you don't just say, ask for a number, and now you wait forever until they ask for a number. What you're instead going to say is, if they press this button, here's what I want to happen. If they click on this menu, here's what I want to happen. So it's all event driven. When they do an event, you're going to say, I'm going to go do this one thing in response. All right. So why do we use GUIs? Well, the simple answer is it's just what people expect at this point. But the honest answer and the bigger answer is because it allows us to organize the information in a much more useful way, such that people can see it and interact with it in a very natural way. Ideally, the discipline of user interface design, or human computer interaction, HCI, which that is an entire discipline of computer science. You can take classes on that and you will study how people interact with a computer and what is natural and what's not natural. There's entire groups of people in each of the large software engineering companies that deal with the user interface and decide what's going to work for people and what doesn't. And honestly, if you think about all the programs that you use in your life, there are some of them that you stop using them because they're pretty awful. and you expect it to work one way and it really doesn't, and you end up having to fight with it constantly, and eventually you're just going to move on and find something else that's easier to work with. So UI is really, really important. So when you're building something, you need to think to yourself, how would I want to use it? It's really easy to have your developer hat on and you're over there coding and you're getting your stuff done and you're like, well, it works. I mean, all they have to do is click this menu and then go to the submenu and then click the submenu and then open a window, type in this random hexadecimal code and hit submit. Why is that so hard? Well, that's not intuitive to the average person, so people are not going to love your application. So, real important that you think through what would be useful for somebody, and you have to kind of picture, the simplest interface that you can get. Today, a lot of UIs are designed in what's called material design, which is to try and translate things that exist in the real world, like pieces of paper, and then make it so that when you pull up the piece of paper, you can see the text on it. And it's natural, like it scrolls and it works in the same way. And if you want to move to the next page, you do some kind of a gesture, so that it feels natural and you don't have to explain to somebody how to use the GUI. All right, so the next topic here is that there is a difference between front end and back end coding, and we're going to talk about that for just a second here. So everything you've done so far, the front end and the back end is really the same code. You ask the user for a number and you sit there and you wait until the end of time for them to type in a number. But once you start needing to separate the two things such that you have the ability for the user to only press things when the user wants to press things, then you have to have a GUI that is waiting for them to do stuff. Well, that's very different than what you might need in your code on the back end that may be doing some kind of transactions. So if we think about a bank, which you guys did a lab a couple of weeks ago where you had to calculate interest. And one of the questions that a couple of people came to us with is, well, when is the interest actually calculated and who's really calculating the interest? And really what they were telling us there is that logically in their mind, it didn't make sense that you're writing this GUI program where there's a menu and you can say make a deposit, make a withdrawal. When does the interest ever get calculated? It doesn't make sense. Somebody would have to say, calculate interest on this account now. What would instead happen is that there's some background process that once a month it would wake up and it would go ahead and calculate all the interest on all of the accounts and update all of the accounts automatically without the GUI, the front end, having to have that. So this is the concept of separating two parts of your application. In some cases, it'll be separated into three. And I can give you an example that I had from a previous company. So where I last worked, there was an inventory system, and we had to keep track of all of the servers in our data centers, which was thousands and thousands of servers. So obviously, you're going to need some kind of a database or some kind of storage area to store all of the information about all of those computers, which that's great. That's going to be your backend. And it will have to have the ability to update information about a computer or get information about a computer or note that the computer has been turned on or off or disposed of or it's broken or it's caught on fire or whatever's happened to it. And then separately, there needs to be a front end where people can go and actually enter information about new servers that are coming up online or servers that are being deprovisioned or things that they have done an upgrade on or added an IP to or whatever it is that they may have done to it. So the front end in that case was a web application. They went to a URL and then they got an application in a web browser. And the back end, as I mentioned, was a bunch of code which interacted with the database to keep track of all the info. But in that case, the weirdness was that there was more than one front end. So there's the concept that somebody might need to come and manually type in information about a computer, but there was also the concept that we had a lot of automation that added machines and removed machines when necessary. So for example, if you have an application and there's going to be a surge of users, think about somebody like a Ticketmaster, for example. When they sell tickets to a big concert, which of course concerts are not working right now, but let's pretend that they are. When they sell tickets to a big concert, they're going to get a huge number of people who are going to hit them all at once. And so just before that happens, ideally, in their data center, they're going to spin up a lot more servers to handle all of that load. And then as soon as it's over and done with, as soon as all the tickets are sold, we're going to automatically compress back down to a smaller number of servers. Well, that means that in the inventory system, you're not going to have somebody manually entering all those in the UI because it's an automated process. It's spun up and it's spun down automatically. So there's going to be some other application that's going to need to reach in and tell the back end that a bunch of servers have appeared or disappeared. And so that's where you're going to get the idea of a middleware. A middleware is an interface between the back end and the front end. And you're very commonly going to get this called, you're going to hear this called as an API layer, which is a set of programming interfaces that you are making public from the backend that the front end will consume, meaning that the front end will write code against those APIs in order to call them and ask them to do something. But there may be more than one front end that's doing that. So there may be this automated one that's chugging through and it's making and removing machines simultaneously to you may have 2 or 3 users on the website who are adding and removing stuff. So the concepts were there's the backend, which really doesn't care about the user. It only cares about the data. How do you put the data in the database? How do you get the data out of the database? Are there any automated processes that need to happen on the data that run in the background? That's the work of the backend. The work of the front end is purely to give the best interface for a user. And then the front end is going to tell the back end what it is that the user is trying to do. So the way that it tells that in some cases is that there's a middleware in between the two of them where the front end tells the middleware and the middleware tells the back end. And you might say, well, why do you need this extra layer of indirection? Because the way that a user interacts with something and the way that the back end interacts with something are usually quite different. So you may need something that translates between the two. Think of the middleware as a translator. If you were speaking to somebody in a different language, then you need a translator in the middle that says how to talk between the two. The middleware also gives the ability for there to be more than one front end, which is quite common. As a matter of fact, very strangely, I'm teaching these slides out of Google Slides. And there is a front end in Google Slides, and I have menus up here where I can click on things, and I can go into boxes, and I can press buttons on menus, and I can move between the slides. But on my phone, I can pull up that exact same slide presentation, and I get a very different interface on here because my phone is a much smaller device. So on my phone, I don't get the ability to do all the same things that I can do up here. I get a much simplified one. So these are two examples of two different front ends. There's a fully fleshed out web front end, and then there's a smaller mobile front end that allows me to do the things that I'm most likely going to need to do on a mobile front end, but it's not encumbered by all these buttons. Because on a screen of this size, I can't get to every single button. They'd be tiny. It would be awful trying to do that. So I don't want to have a million buttons on there. I just want something very basic. So a tenet of GUI design is that you present to the user only the things that they need at that given moment. It should be a very simplified view that makes sense in their head and allows them to do things naturally. That may be very, very different than the back end, which is dealing with things quite often in a very unnatural way from the perspective of a user, because what it cares about and what the front end care about can be two radically different things. So hopefully that makes sense between the two. All right, so let's talk about some common parts of a UI. So on the right-hand side here, we have a calculator, and you've all seen this, and I guess there's one here on the computer that looks a little bit different. I took that screenshot from a Chromebook, and this one is from a Windows machine. But both of these have a bunch of things in common. So the numbers are laid out in a logical way. And interestingly enough, pretty much all calculators put the number 1 at the bottom left and then work their way up to 9, which is actually weirdly the opposite of how telephones do it. If you ever look at a telephone, you'll notice that 1 is here, and then 2, 3, 4, 5, 6. At some point in the past, somebody said that this made a lot of sense, and then it's a legacy thing. If you had, I don't know if you've ever seen a movie where somebody has like one of the old-fashioned calculators on their desk, and they're like, people have learned to type on calculators based on the fact that the number 1 is in the bottom left corner. If you change it suddenly, people will have a really hard time adjusting. So there is a convention that everybody uses that the number 1 is at the bottom, but weirdly in phones, we decided to put it at the top. So my point here is you do what's natural and what is expected, even if it doesn't really make a whole lot of sense. All right, so you'll notice that the buttons here are laid out in what's called a grid layout. And what that means is it's laid out logically column by column. And even if I stretch and shrink this window, you can see that they don't change their positions. It would be very bad in a UI if as I shrink, the buttons changed where I was going. You'll see that sometimes, like up here, all of these buttons that exist inside this browser window, if I shrink down the browser window, I can make them move around to some extent. And actually, it tries to be very careful about what it wants to keep on my screen versus what it will happily hide off of my screen. I'm just going to close these out because I'm done with those. So there is some thought about where buttons are and when they move, And that's something you have to do. But a grid layout is a very common layout where things are just laid out pretty much in rows and in columns. This seems relatively natural to most people. So you'll see a grid. It's sometimes also called a table. If you think about like Excel or a spreadsheet program of some form, you're used to seeing things laid out in a grid. And that's why they're so popular. People frequently put information into Excel spreadsheets because it's laid out in a nice logical fashion. Another option is that you might have a tree, and most menus end up being a tree. So, like for here, I have an initial menu, and then I can drill into a child or a branch of that tree, and then from there I can go into another branch of that tree, and I can get to some other information. So this is sometimes called an accordion, it's sometimes called a tree, it's sometimes just called a menu, but these are all examples of layouts that you will use when you're putting information on your screen. The last one that's mentioned here is cards, and you'll see this a lot today. A lot of UIs nowadays have cards for different things. Um, and so cards are just a way that you can organize information where you have more than one of them on a screen. If you think about if you have any kind of a note program that you use, like OneNote from Microsoft, or if you're using Google Keep, or if you're using any other note keeping program, you'll tend to see the notes as individual cards inside the UI, and then you'll move around inside of there to move things around. All right, and then the users interact with the GUI through a number of different things. So we've already seen menus, that's up there. They may have buttons, so I can highlight this and I can make it bold by clicking on a button. So this is a button that's up there. They may have selection lists where they're choosing from something. So if I come here, these are all the different fonts that are supported. And so I would choose which one I want. That's a selection list. Radio buttons are a special kind of selection list. They only let you select one thing, whereas checkboxes are a different kind, which allow you to select more than one thing. And depending on the circumstance, sometimes you need one, sometimes you need the other. A date picker is a common thing. So that basically is going to render some kind of calendar and allow me to choose a time and or a date. A file chooser is a similar idea, except it allows me to, like open up a new file. It's going to give me a list of all of the folders and allow me to select a particular folder that I wanted and go from there. Labels are simply just text that's on the screen. So like if it's not a button, it's probably just text on the screen. And I don't see a good example of that here because almost everything on the screen is a button in one way or another. But if it's just plain text, it's a label. You may have knobs and sliders. These are just ways of adjusting something. Typically, when you're dealing with a volume, you're going to have a slider of some form, which allows you to select up or down what number you want, and that makes that ding in my ears, which is not great. Links. This is a link here, and you know that anytime it's underlined, you're used to the fact that that's going to bring you somewhere else. And then you might have a progress bar, which you're familiar with those as well when you try to open up some piece of software or you're opening up your game system and it suddenly decides it has to apply a update and you're like, oh, good Lord. So the progress bar shows you how long. So these are different UI elements that you might have to deal with as you are using your UI or as you're designing your UI, which is what we're going to do. All right, so let's talk about how we lay things out. So clearly in this UI that we're looking at here, there is a decision that this file menu is going to be right here in the top left corner. It's not all the way up in the very top left corner, but it's pretty close to the top left corner. And then the edit button is going to be next to that and so on. So somebody made a decision as to exactly where each of these things are. Now, to be clear, as I mentioned, if I shrink and I grow the window, sometimes those things will move related to each other. They'll move in proportion to each other effectively. But you will always specify where things are using a grid system with two coordinates. So for example, both Java and C# use the same coordinate system. The top left corner of the window, wherever that may be, all the way up in here in the corner, is going to be position 0, 0. The bottom right corner is going to be the highest number, comma, the highest number. And you might say, why are you being vague about that? Well, because it depends on how big the screen is and what font size you're using and what resolution you have as to exactly how big this is. So you will specify how big you want your window in pixels. 600 pixels is a relatively small amount in a high resolution screen, but if you're on a lower resolution screen, 600 may be the full size of the screen. So when you set up a computer, at some point you had to choose the resolution of the screen. And that's usually dependent on your monitor as to how far you can go in that. I don't know what resolution this is at, but it's probably relatively high, probably like 1900 by 700, give or take. It may be something more than that. So you're going to specify a number. All right, so how would you put something right here where this dot is? Well, you would specify the first number, which is it gets bigger as you go along this axis, the x-axis. That's the first number. So according to this, this is 75 pixels away from the edge. And then you specify the second number, which gets bigger as you go further down the window. And in this case, we're saying this is 60 pixels from the top. So 75 over, 60 down gives you that spot. Whereas 350 over, 250 down would get you to this spot, and so on and so forth. So anytime you're putting something on the screen, you're going to need a two-digit number. A set of two digits, the x coordinate and a y coordinate. If we were going to draw a line from here to here, I would specify that the line will begin at 7560, which is two digits, and then I would say it ends at 350, 250, which is there, and that would have the effect of drawing a line down here. I do not want to pick that up. I thought that I was drawing. I am totally not drawing. There we go. That would draw a line that would be much straighter than that, but it would draw a line somewhere along this general place. All right, so that is how we deal with positions on the screen. And okay, good. Got rid of the eraser. Go away. I have made terrible decisions. All right. Now I don't have access to, yeah, we're going to pause for a moment. Okay, I have figured out how to get my mouse back. All right, so the next thing we're going to talk about is colors. When you're designing UI, you will use colors in different places. Colors are very, very useful for giving information to people or catching people's attention. If you think about every graph you've ever looked at, there's probably multiple colors on the graph. Why? Because it allows you to convey information in addition to the height of the bars or the size of the pie slices or whatever else. So color is very useful in a UI. It also allows you to see things that you're allowed to do and things that you're not allowed to do. It's quite common that if something is not possible, it's grayed out so that you know that you can't actually do that right now. So how do you go about defining colors? Well, to most computer systems, colors are going to be defined using what's called RGB, which is red, green, and blue. And in each one of those cases, you're going to specify a hexadecimal value. So let's talk for just a moment about hexadecimal in case that's not something that you've used recently or something that maybe you've never heard of. So everything that we do today when we talk about numbers, we deal in decimal 10. Why? Because, well, we were born with 10 fingers, most of us. So for whatever reason, we decided that 10 was the magical number. What I mean by that is if you're counting, you're going to start off with the number 1, then go to 2, then 3, then 4, then 5, and all the way up until you get to 8 and then 9. Once you get to 9, if you need another number, you now need 2 digits. You increment the next number to a 1, and you go back to 0 on the second number. So then you go 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. And when you get to 19, you add 1 more to the first number, which brings you to 20, and reset back to 0. So you're dealing with a system where there are 10 digits, 0 through 9, and every time you reach 9, if you need another number, you have to increment the next digit over. That's how regular numbers work. How hexadecimal numbers work is pretty much the same thing, except there are 16. You know, like you were born with 16 fingers, because that makes sense. But anyway, so in hexadecimal, the numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then for the number 10, as we would know it, that's represented by the letter A. 11 is represented as B. 12 is represented as C. 13 is D. 14 is E. And 15 is F. Once you get past F, if you need to go to 16, then you would represent that as a 1, followed by a 0, because you go back to the beginning again. So 1, 0 in hexadecimal is 16. 1, 1 in hexadecimal is 17. And then all the way up to 1F, at which point you move on to the next letter, which is 2, 0. So if we take a look at here, any number in decimal that is lower than 9 is the same in hexadecimal. So if you're dealing with 7, it is 7 in hexadecimal. It only starts getting screwy once you get to the number 10. So 10 in decimal comes out to A, 11 is B, and all the way up to 16, which is F. And then, as I say, that's as big as you can do with a single digit. So now you need 2 digits to represent the next biggest number. So 17 comes out to 10. Okay, so I noticed that there was a typo on that slide, which is why I paused and I'm back. I apologize. This a moment ago said something slightly different, which was incorrect. F is indeed 15, not 16, as it recently a moment ago said. So I'm going to go through that example one more time. So if you are at F, which is the last single digit you can have, which is the representation of decimal 15, and you want to add one more to it, then you're going to start a second digit, which is going to be a 1, and you're going to reset the other digit back to 0. So the number 10 is 16 in decimal, whereas 17 is 11. The rest of the slide was correct. So 26 is 1A. That's the you're getting into the letters again. So that is effectively a 16 plus a 10, and that's why you get 26. And that would go all the way up to a 16 plus a 15, which is obviously 31. And then you would move on to 2, 0, and so on. If you go all the way up to FF, which is the biggest thing you can represent with 2 hexadecimal characters, you're at the number 255, which is very relevant. So hexadecimal is a more efficient way of writing bigger numbers because you can do it with less numbers. That's part of the reason for using this. But FF is something that you're going to become very familiar with because it means 255, which is the highest value you can set for either red, green, or blue. So when you're dealing with a hexadecimal value, and this is useful if you ever do any web UI stuff in writing HTML, all the colors are going to be specified over here in this way. You're always going to give a set of 3 numbers that are each 2 hexadecimal values that specify how much of each of the 3 colors you want. So the first color is going to be red. You will always remember it as RGB, which will tell you it is red, then green, then blue. That is an order you just have to memorize. It is always going to be stated as RGB. So if you wanted the color red, you would specify all the red is turned on, none of the green is turned on, and none of the blue is turned on, and that gives you pure red, which looks like this number right here, or this color right here in the middle. If you're wanting green, then you would say no red, all the green, none of the blue. And likewise, if you want blue, it's no red, no green, and all of the blue. And then you can mix colors. So if you want yellow, you're going to turn on all of the red and all of the green, and that gives you yellow. If you're wanting purple, you're going to turn on all the red and all of the blue, because that's how you make purple. I will point out that if you are somebody who deals with paint, and you're thinking, I'm sorry, you make yellow by doing what now? Yes, it's different for paint than it is for light. These numbers represent how you do it with light. So if you want to make white light, the way you do it is you turn on all the red, all the green, and all the blue, and that will give you white light. If you want black, you turn off all the red, all the green, and all the blue, and the absence of light gives you black. So just be aware of that because this is quite different in colors. There is no way that you can make white paint by mixing red, green, and blue paint. That's not how that works. So you're dealing purely in light, so remember that. So over on the right here, here's just how you would get the different values that represent different shades of red. There are millions of these charts on the web, so you're basically just going to Google the number, but you can also play with it a little bit. So you can see that like these pinkish hues at the top of the red chart are made up by all the red being turned on and then part of the green and blue being turned on. And just depending on how much of it you turn on and what proportions you get, that gets you closer and closer to a pure red. And then likewise on the other side, you're just turning off more and more of the red until there's no red, at which point you end up with black. So that's how you get darker reds. You just turn down the amount of red light you turn on. All right, so that's how you do colors. So hexadecimal, 2 digits. FF represents 255, which is the most that you can specify for how much of each light you want turned on. And there you go. Look up a chart if you're having a hard time figuring out how to make a particular color. There's lots of them online.